Hi, in this video I will show you how to simulate a Verilog code in Cadence Virtuoso. As you see on the screen, I have created a step-by-step procedure for this simulation. This procedure you can find on my GitHub account under this name. The repository includes two files, which one of them, node.v, is a Verilog code, and the second one is the test bench. And of course, the README file where these steps are described. So let's start. I will push this window aside so that we can see both the repository and also Cadence. I have already started my Cadence Virtuoso, so the first step, we need to go to the library manager and let's create a new library. And let's call this AMS_test, for example. And we not need any process information now. So select this bottom line. Select the library, and in the second step, we want to create a cell view. So go to the cell view. Let's call this cell view as node_engage and select a Verilog and hit enter. Okay. So you see on the screen the text editor will appear. So this is a place where we can put our Verilog code inside. The Verilog code for this design is in the repository under node.v. So you can copy and paste this code. I will write it simply now, because it is a very short one. Sign y. So this is exactly the same code as we see here in the repository. So we can build the instance, and this tool will ask you if you want to create a symbol for this design. We won't, because we do not work with the symbols. So close this window, and on the right side you see this functional. This is the Verilog code which we have created. So go back to the repository and see what's next. So now we are on this point, so we need to launch our NC-Verilog tool. This you can run from the command window. Go to the tools and hit NC-Verilog. In this small window, we need to browse through our design. Double click on function, and let's create a run directory, which we can call, for example, node.gate run 4. Go again to browse. Okay. Now you see this initialize design is activated, so you can press this to initialize this design, and the next one is already ready. Generate netlist, and the last one, simulate. So we need to wait a second to open the simulation analysis environment. In this tool, we see here on the left side that our design has been created and is ready for run. So these are the input and output signals. We can select this both, right-click, mouse button, and send to the waveform window. So the waveform window appear, and we can select input and output and hit this run button. Let's increase the time. Okay, so you see on the left side, the input A has a value of 0 and the output has a value of 1 all the time. So this is nice, but we want to improve this test bench so that we see the changes. So for example, we want to set the input, initialize the input as 0, as is already done here, but what we want to change it to 1 and again to the 0, so that the nice digital signal has been present. This is described in this point. So now let's close this, and again select both output and input, and right click, go to the send these signals to the source browser. In this window, the tool has already created for us a test bench. In this include file, you can find the stimuli for this test bench. So let's go to this file and see what is inside. This file is in documents, not gate run 4. So let's go there. Not gate run 4, and this is this file. So let's open it, and you see this file include this simple stimulus where the input is all the time 0. We want to change this, and how to do that? You can go to the repository and see the test bench here. So let's add 100 nanoseconds, 1 and tick B1. So this line change the input signal to 1 after 100 time units, and sorry, it should be work. Okay, now. Oops. This one, okay. And now we can change this again to the 0. So initial state is 0, then after 100 time unit changes to 1, and again after 100 time units changes again to 0. So let's save this new test bench, close this windows, this one also, and see if we can see any changes. So let's select the input and output signal, change this to 200. Run again. Okay, there's no changes in our design. Okay, let's close this window, and also on this one. Yes, I want to exit, and let's run this. Let's go to the commands and let's see our stimuli. So edit a test fixture. We can check the syntaxes. Verilog is successfully analyzed. Okay, and the stimuli also. Okay, it's syntaxically correct. Okay, let's initialize again. Do you want to keep the previous run directory environment? Actually, yes. And generate new netlist. Yes. And simulate again. Okay, so click on test, select both input and output. With right mouse button, click and select the waveform window. And now they both are selected, so hit run, and you see that our Verilog inverter works properly, because if the input is low, the output is high, and after 100 unit time, nanoseconds in this case, changes the input to 1 and the output properly to 0. So this is what I want to show you, and yes, that's all. So thank you for watching, and I will see you next time. Bye.